Hello, Happy New Year. Welcome to 2019, or whatever year this is that you're watching. The title of the first lesson is Area Up To Notes. And I've graphed this triangular and circular and straight line graph. This is the point 22, this is the point 40, this is the point 6, -2. This is the point 80, and then this is the point 11.2. And you might want to pause the video now and make sure you get that graph nicely. Okay, so we're going to look at this weird function, g of x. And g of x is the area from 4 to x underneath f of t dt. And I should tell you that this graph is a graph of f of t. So again, this is a strange function. There's lots of stuff going on here. This is the integral symbol. Remember, that means find the area. And then there's this function f of t dt. So for part A, we're going to find g of 11. All right, now the weird thing about this function is when you plug 11 into g, the 11 goes there. See how the x is upstairs on the integral? Doesn't go here because that's a t. The input variable in g is x, so the input goes there. So for example, if you put 7 into g, you'd find the area from 4 to 7. If you put 20 into g, you'd find the area from 4 to 20. So that's why I call this the area up to function, because this function finds the area from 4 up to whatever you plug into it. So for this problem, G11, that means find the area up to 11. Find the area from 4 to 11. Okay, so to find G of 11, we're going to do 11 in that spot because that's the input. So all we have to do to figure out G of 11 is find the area under f of t from 4 to 11. So going over here, here's 4, and here's 11. So that means we're going to find the area from there to there. So luckily, this is a nice shape that we can deal with. This is a half circle, and this is a triangle. So to find the area from 4 to 11, that's just going to be the pi r squared for the half pi r squared for the half circle, and then 1/2 bh for the triangle. And we're going to add those together. So let's look at the triangle first, because that's a little simpler. The base of the triangle is 3, 1, 2, 3, and the height is 2. So 1/2 times 3 times 2 is the area of the triangle. And then for the circle, here's the center of the circle, and it goes 2 this way, and 2 that way, and 2 down. So the radius is 2. So that's going to be pi times 2 squared. Okay, now you might remember that when you have area under the x-axis, that area counts as negative. So this area here is above the x-axis, so we're going to count that as positive. And this half circle is below the x-axis, so we're finding the area up to the x-axis. And that counts as a negative area since it's below the x-axis. So then this is negative 2 pi plus 3. And we'll just leave it like that. And we could get a decimal for that if it was calculator active. So the final answer for G of 11 is negative 2 pi plus 3. Okay, let's also do G of 0. So G of 0 would mean put a 0 where the x is. Again, this is a strange function where the input is up there. The input variable is x. So we find the area from 4 to 0 if we were finding G of 0. So we'll come back over here. And we're supposed to find the area from 4 to 0. Now this time we're going backwards. So that's the other way that you can get negative area. There's two ways to get negative area in calculus. First way is, if your function's below the x-axis, then that counts as a negative area. And then the second way is, If you're going from 4 to 0 instead of 0 to 4, then since you're going backwards, that area counts as negative. So this is going to be a triangle, so 1/2 base times height. The base is 4, and the height is 2. So area here is 1/2 times 4 times 2, which comes out to 4. And again, since we went backwards, that's going to be counted as negative area. So the answer is -4. Good to see you again. I know you're excited to get back to school, and I'll get to see you in person soon. Thanks for watching.